In today's video, we're going to be looking at the math section of the ACT practice test. This is split into 5 different sections with 12 questions each, and this is the 4th section that we're looking at today. I will have the links for all the other sets down in the description box below, so go check those out, and feel free to check this out at act.org and give these a try for yourself. If there's a different strategy you'd use for any of these, please comment that down below so we can all see some different strategies for these problems. Starting with number 1, we have a geometry problem. Looking at these 2 triangles that intersect, they want us to find the angle FCB. They tell us A, B, C, and D are collinear, meaning they are on the same line, and they also tell us that FC is parallel to ED. That is going to help give us the information we need to then figure out the angle. So I first started with the fact that A, B, C, and D are collinear, meaning they are on the same line. So that means that angle there with the 147 degrees, that inside angle, together they make a straight line, which is 180 degrees. So if I take 180 minus that 147, I get that that missing angle there is 33 degrees. Okay, now that is not the angle we're trying to find though. We're trying to find that other angle, and that's that tiny triangle in the middle. Okay, but that does give me the second side to this right triangle, which we know a triangle is also 180 degrees. So 180 minus that 90 degree angle. So then we have 90 minus the 33 we just found out. So we know this angle here is 57 degrees. Now remember, we were told that those 2 lines were parallel. So we have the angle relationship between those 2 angles. You'll notice they're both the upper left of the transversal. So that means they are corresponding angles, which means they are congruent. So if that angle is 57 degrees, our angle over there is also 57 degrees, option B. Now on to number 2, I noticed there was a lot of geometry in this section compared to the other ones were more algebra focused. So here we're trying to find the equation for a circle where the center's at 0, 0, and it passes through 3, 4. So whenever your center of your circle is the origin, 0, 0, it's just going to be x squared plus y squared equals whatever your radius is squared. So I'm going to draw a nice little picture here. I got my center at 0, 0, and then it tells us it passes through 3, 4. So I just kind of drew that out to get an idea of what my circle is going to look like. It's going to be 3 out and 4 up, and notice, so that'd be my circle. So to get the radius, it's going to be basically the hypotenuse of that triangle I made. So we can use Pythagorean Theorem. A squared plus b squared equals c squared being your hypotenuse, which is our radius in this case. So we get 3 squared is 9, 4 squared is 16, add them up to get 25, and then square root of the radius would be 5. However, we just want the equation, which would be option J. Moving on to number 3, 3, 4, and 5 go off of this picture to the right here. We have this triangle where there's 3 pieces of lumber, links 4, 5, and 6 to create this flower bed. Now question 3 asks us if, given those links 4, 5, and 6, and knowing that each cut takes 1/8 inch of wood, what is the shortest the piece could be of wood to be able to create this flower bed? So first of all, we already know we have our 4 foot, 5 foot, and 6 foot. And they are wanting this in inches. So first thing I did was figure out what 4 foot, 5 foot, and 6 foot would be in inches, which 1 foot is 12 inches. So I just took each of those times 12. So I got 180 inches, which is looking like option C, but remember each cut takes 1/8 inch of wood. To cut this into 3 pieces, I'd have to make 2 cuts. So those would each be 1/8 inch. Meaning 1/4 inch in total, so I'd actually need 180 and 1/4 of an inch, making the answer option D. So number 4, they're wanting us to find that outside angle B, and given that we have the inside angle is x. So now our interior and exterior angles of a triangle should equal 180 degrees together. So if we know they should be 180 together, say we were given x, we would just subtract that off from the 180. So to find b, we would just take that 180, subtract off x. So that would give us option I. All right, and then the last question on that picture, it says, what if we were to change this to a right triangle? Keeping those sides of 4 foot and 5 foot, they want to know, instead of 6 foot, what would that new hypotenuse have to be if we changed that to a 90-degree angle? So this is just another Pythagorean theorem problem. A squared plus b squared equals c squared, c being your hypotenuse. So 4 squared plus 5 squared equals x squared. 4 squared 16, 5 squared is 25. We add those up to get that x squared is 41. To get rid of squared, we square root, which the square root of 41 is approximately 6.4, option D. In number 6, they ask us which of these expressions are even, meaning which of these expressions are divisible by 2. So if you go through looking at that very first option, 8 and 2 are both divisible by 2. So I'm going to go ahead and say that that is an option. Looking at the others, 3 and 3, not divisible by 2. 2 is, but C is by itself, meaning there's a 1 in front, not divisible by 2. I is 1 and 2, not divisible by 2. J is 1 and 1, not divisible by 2. So I'm seeing the only option is option F. Moving on to finally an algebra problem, number 7. They tell us 280 children are either 11 or 12, and if you were to add up all of their ages, we'd get 3,238. So starting off, let's get our variables. 11-year-olds are x, 12-year-olds are y. We know together there's going to be 280 of them. If we add up their ages, so remember our x is 11, so 11x, and then remember our y is 12, so 12y. If we were to add up all those ages, we'd get 3,238. Now I have my two equations. It's just solving and plugging in. I want to know how many 11-year-olds, which is my x, so I'm going to get rid of all the y's in my equation by solving for y in my first equation. We know y is the same thing as 280 minus x, so in my second equation, instead of y, I'm going to put 280 minus x. And now it's really just solving it out. So I'm going to keep that 11x in front, and then we need to distribute our 12 onto both things inside of our parentheses. So how to use calculator here for that part. And now combine our like terms to get that negative x plus the 3,360, which we need to subtract off. To get that negative x equals negative 122, which means positive x would equal positive 122, option B. In number 8, we go back to the geometry problems. So we have 4 semicircles and then a square in the middle with each length being 10 centimeters long. If we want to find the total area, we need to find the square and the semicircle. So starting with the square, length times width, 10 times 10 is 100. And then we have 2 circles, right? 4 semicircles, meaning 2 circles, which the area of a circle is pi r squared. We are given the diameter is 10, so that means our radius is 5. Plugging in, we get that each circle is 87.5. Remember, we have 2 of them, getting us a total of 157 plus the 100 gets us 257, so approximately 260, option H. Number 9 is also a geometry problem. I'm telling you guys, this section is the geometry section, I guess. And we are wanting to find the height of this triangle. Right, so we are going to have to use our trig functions to find that height. So we're also given those angles, and we're given the whole length down there is 30. So if that's cut in half, we know that that length right there is going to be 15. From here, we can use our trig functions, so, ca, toa. If we're looking at the angles, we're wanting to find the one across, so the opposite, and we're given the one next to our angle, our adjacent. So which one uses opposite and adjacent? Tangent, toa. Tangent is opposite over adjacent. So tangent of our angle, which is 20 degrees, is going to equal our opposite, which is h, over our adjacent, which is 15. from here, we want to solve for h. So instead of h divided by 15, we got to get rid of that by multiplying by 15. Do that to both sides to get that h is 15 times the tangent of 20, which is option A. Moving on to 10, we have another geometry problem. So we have this quadrilateral here, and they tell us that EF is on point AD, and they also give us that G is the center of the rectangle BCEF. So right away we know that's a rectangle, meaning their opposite sides are going to be congruent. All right, we are wanting to find the length of AG, which if you look at AG there, you can tell it is actually a hypotenuse of a smaller triangle, right? If we put that together, we have a right triangle there. So if I'm able to find those two side lengths, then I should be able to find my third side length. All right, so I'm doing some adding and stuff here, finding that that length would be 4, so half of it would be 2. Notice we have 6 and 12, meaning that that length there is going to be 6. So if we were to cut it in half, that length is 3. We have 0 and 6, meaning that length is 6. So we have our long side being 9, our short side being 2. And then we can use Pythagorean Theorem. So 9 squared plus 2 squared equals x squared. 9 squared is 81 plus 4. We get that x squared is the square root of 85, which is our option H. Number 11, we have a graphing problem, so finding the x-intercept. Whenever you're finding the x-intercept, that is just whenever your y is 0, right? That's what makes it go through your x-axis. So if we plug in 0 for y, we're going to look for two numbers that add to get us 4 and multiply to get us -4, which is going to be -2 and -2. So we could have x minus 2 times x minus 2. Notice if I multiply that out, it gets the same thing as the original. If I go to solve this, we get that x is 2, which is option E. And then we're ending with an algebra problem. So they give us this equation with p, t, x, and y, and they want us to solve it for t. So we want to get t by itself. Notice right now it is underneath 3p. So we're going to get it out from the bottom by multiplying by 2t. So that gets us 2tx over y. Remember, we're solving for t, so we got to get rid of that y by multiplying by y. We get 2tx is 3py, and then we have to get rid of that 2, so divide off 2 and divide off x. So we end up with option J, 3py over 2x. Thank you so much for watching this video all the way through to the end. Please give it a thumbs up if it was helpful, and make sure you subscribe so you don't miss more math tips from me.